Is now starting. All attendees are in listen.
All right, good afternoon, everyone, and thank you for joining us on our January 12th tornado review. Myself, Keith Stellman, and Kyle Thiem will be walking you through the pretty intense review of the data from the January 12th tornadoes and everything we found along the way during this assessment. So, first of all, why are we doing this update? We initially had an assessment out following our ground surveys. But what we could see from our initial assessment was that multiple tornadoes were likely in this particular event on January 12th. The one thing the initial assessment lacked from the days following the event was high resolution imagery to help us make sense of it all on the ground. The damage was extremely widespread, in some cases 2 to 2.25 miles wide. And so the initial assessment lacked the ability to try and resolve some of the details that were happening within that 2.5 mile span where the damage occurred. But because it is a rare event, we wanted to make sure to get this as correct as possible and explain to everyone impacted what actually happened that day. So that's why we're doing this update to the tracks and the information. So as a big picture, this was a supercell thunderstorm that started off in near Selma, Alabama, and tracked all the way across south central Alabama and crossed into Georgia just northwest of LaGrange in Troup County. And it was at about that point that it underwent a process where it evolved into a large mesocomplex. But all in all, the span of that one particular storm is around 217 miles, where it created quite a bit of damage along the way. So following the days, we put in an aerial imagery request through the Geospatial Insurance Consortium, and they flew the areas that were put in where we actually had debris signatures, and it was, again, our first guess at where we expected to have the damage. And that imagery came back, and what you see here are the swaths from both January 12th, from starting in Troup County through Meriwether, and then for much of Spalding County into Henry and Butts County. What you see to the north there is the Noonan track that was flown following the Noonan tornado. And again, that imagery still exists in the database that we're able to use. So let's start with the storm just before Troup County. You can see the main supercell near 5 Points, Alabama. Also note the squall line feature that's beginning to evolve just west of the Georgia line. And you can see the Georgia line here. You can see LaGrange. Let me draw on the screen a little bit. Here's LaGrange over here on this point. And you can see the squall line starting to evolve here. This is the main parent supercell in circulation. And then the tornado would be right around little 5 Points. I've highlighted in the yellow circle, or the white circle. What is evolving here ends up being a pattern that repeats itself several times in the evolution of this tornado as it enters Georgia. And we're going to get into that here in just a minute. So moving on. Here's a snapshot of the main supercell as it's pushing into Troup County. You can see it near Evansville. The velocity signature on the right-hand side of the image shows you the tornado itself. Did cause some EF2 damage as it was coming into Troup County in the northwest part. Obviously, no sign of anything moving towards LaGrange at this point. This particular tornado actually tracked, eventually weakened and died as it approached the area northwest of LaGrange. But you can see there's obviously nothing we're tracking at the current time moving towards LaGrange. But it's the evolution of this particular supercell that, again, is what we referred to, and we see it several times throughout its life cycle. Moving on in time. Here we are a few minutes later at 3:31. In fact, that last slide was 3:24. Here's 7 minutes later. We now see a new surge developing south of the parent circulation that was to the north in northern Troup County. That new surge that I'm pointing out here becomes a tornado 3 minutes later, just south and southeast side of LaGrange. And again, it starts the pattern of evolving into a large mesovortex as it moves to the east-northeast. Here's a blow up of the area in and around LaGrange and Lexington Park Drive area, which we surveyed on the ground. Some of the aerial imagery you can see on the image here. That's what we get from the plane. Some of the things to point out on this image, you can see the tree damage in and behind these trees. The trees blown down. Here's some over on the right-hand side. The houses themselves, and what I've got here are two shots from the ground of those houses that we see from above. And so you can see the extent of the damage in that particular vicinity from the tornado as it crossed through on the southeast side of LaGrange. Erase this. All right. Tornado continues east. We're now east of LaGrange, approaching the Meriwether County line. And the main tornado itself, I'll highlight on the screen, it's right here. Somewhere in this blob, you can see the main circulation. It's pretty large overall. Of note, just like what happened in LaGrange, we're starting to see a new surge coming up from the southwest on the east side of the tornado. That will eventually evolve into a new tornado. And I'll erase this. On. Here we are 4 minutes later. You can see two separate independent circulations. So a new tornado has just formed inside the Meriwether County line. Both of them, both from aerial imagery and ground surveys, do appear to be on the ground at around the same time, somewhere in that 345 to 347 window. Both of them were on the ground right near the county line. Confirm that. One of the things we look at is debris signature, or TDS. What you're seeing here, these blue areas are tornado debris signatures, and they match up with a circulation here and a circulation here associated with both tornadoes as they're migrating into Meriwether County. So, give you a little animation, just the whole process. Play this forward. You can see the one tornado, the LaGrange tornado, begin to pivot east. The new tornado forms, pivots to the north of it, and then it eventually pivots and they merge and shift east and cross the rest of Meriwether County. Again, they appear to be both on the ground around the same time at between 345 and 347. All right, we get into the Meriwether County section. The storm overall was relatively well behaved in terms of not doing any recycling, but it was at about this point when it's to the north of Greenville that it caused the most extensive damage and reached its EF2 rating. That was around 355 to 358 in the afternoon. I think I got a zoom in here. Here we are east of Highway 41 along Alley Road. And you can see from the aerial imagery on the bottom left, the tree blowdown and what that looks like from the air. And I want you to keep this in mind, this frame of reference for mine, because we're going to see a lot of tree blowdown that looks like this from the air, from the aerial imagery, and then match that up with what you see on the top right. That is what it looked like from the ground. And so it gives you some perspective of what this kind of damage from the air looks like from the ground itself. Likewise, you can see the mobile home that was destroyed and what that looked like from the ground level in and around this area along Alley Road. Okay. So now we're going to fast forward to the rest of the way across Meriwether County. The storm begins to go through a cycle, and we end up with a wide area of damage. And we all heard about what was happening in Griffin and Spalding County and Northwest Pike County. And so for the days following, we went out and surveyed on the ground. We got up in the GSP helicopter and flew it to try and make sense of it all. There was a lot of damage. Like I said, in the pre, it was about 2.25 miles wide at its widest point, just southwest of Griffin. But what we originally thought, this is what we first put out in about a week following the event, based on what we could make sense of on the from the surveys that we had conducted. We saw the Meriwether storm coming in. We saw it weaken. We were able to at least believe we plotted it up with this track based on the damage on the ground. We saw a new circulation form on the south side of the main vortex that was coming up through here. And we were able to plot damage along this path where it fed in and ultimately in and around the point where it became an EF3. It was a shorter lived tornado, but that's what we originally thought. And then we could certainly see the one that became the Griffin tornado surging up from the southeast, just like what had happened in Troup and in Meriwether. We saw a new surge forming coming up from the southeast or southwest, and ultimately that became the main tornado. That's what we originally thought. So let's talk about what happened and some of the methods that were used to figure out what really happened that day. And this screenshot is from like 4:17 in the afternoon on the 12th. You see Griffin up here to the northeast of this area. I'm highlighting at this particular moment 3 separate circulations that were identified. But one of the first things we did was we requested Geospatial Insurance Consortium imagery the following days. That came in a week or so later. One of our senior forecasters, Kyle Thiem, reanalyzed the data frame by frame without looking at ground data, knowing that we had multiple tornadoes on the ground. And then myself, I went back and analyzed the aerial imagery with the radar analysis that Kyle had done. And what Kyle did was based largely on what he did in his master's thesis work with the El Reno tornado. Kyle created a template by which we were able to then map back to the ground data and the ground indicators to come up with the various track maps that we did. So I'm going to turn it over to Kyle, and he can talk about some of the things that he found during that process.
All right, thanks, Keith. Really appreciate that. So basically, we were breaking this storm down. The main time frame we focused on was between 4 and 4:30 p.m., generally right before this complex ended up moving into the Griffin tornado area. And one of the things I liked about it, we talked about what we originally thought was going on. One of the things we're not showing in this particular image that really highlighted our brains to think that there's something else going on here is we were looking at all the ground damage indicators that we were able to find through our storm surveys. And we realized that something was going on here that we weren't quite able to capture just with our base level of thinking with this complex and how some of the tornadic circulations had formed earlier on throughout the day. So in this image, what we're not showing here necessarily are a lot of the lines that we were able to pick out with some of our damage indicators. And so what this generally looked like, just from rough memory, not only did we have a lot of damage in along these different lines, but we also noticed upon further evaluation, we were getting damage that was crossing, almost latticing through some of these different lines in some of these different areas. And we realized there was something else really going on. So we started diving a little bit deeper to try to understand what was really happening. And so one of the first thoughts was, okay, maybe we have different damage that's occurring from thunderstorm winds that aren't associated with the tornadoes. But upon analysis on the ground, we were able to really see that the damage indicators were pointing in a lot of different directions that weren't really associated more with straight line wind damage. So we knew we had something else going on than these straight storms with damage on the inside. And so another thought then became, well, could this have been a multiple vortex tornado? We were seeing damage that ended up creating a path over 2.5 miles wide. And so at one point we thought, okay, is this a large multiple cyclonic vortex tornado? But that really didn't line up with our current thinking scientifically, because if we had a storm that large, that would be in comparison with some of the largest tornadoes we've observed throughout the continental United States in its history. And the damage we'd see would end up correlating to being a higher degree than what we were seeing on the ground. In addition, there were a lot of spots in between these original tracks that we didn't see any damage at all. And so we knew we had to go to the basics and try to reevaluate this case a little bit further. And so like Keith explained, I went back and kind of looked at our radar data and tried to create a basic picture of really what was going on with this storm. And so we ended up coming with an animation like this. And what ends up happening is we start out with a more or less a supercyclonic circulation. And we end up changing storm modes into a much broader circulation. And we were able to go in through those circulations and find smaller tornadic circulations amongst a broader mesocyclone that ended up having some very complex interactions. So we'll show this animation basically showing all of the circulations we were able to identify throughout this 30-second time period. As you see, each new color is a new tornadic circulation that was identified in the radar data that could be continued. When we actually track these forward and backwards from one moment of time to the next, we were able to see these complex interactions that once we ultimately laid them over damage indicators we were able to collect on the ground and through satellite imagery, found that these actually created a pretty good bones or a pretty good structural composition of what we were seeing. We had to do some fine tuning after the fact that Keith's going to talk about in a little bit. But essentially, what is going on here? I mean, we started this presentation showing the complex tracks without explaining them here, and we'll explain those in a second. But as you see here, we have tracks going a lot of different directions as we start to evaluate here. And essentially what we have going on, I'm going to see if I can back up this animation just a little bit here and kind of breaking down a little bit of the dynamics that are going on. So first of all, within the storm complex, we have winds that are diving down from the north side as a part of this outflow. And along with our inflow boundaries here, we have storms that are coming up from the north. And so what this ends up helping to create is a broader mesocyclonic circulation where we end up seeing a lot of these tornadoes embedded within that broader circulation, which ends up driving them forward in these very complex paths. So as we advance over here to our next slide, it kind of explains it a little bit further. We'll go back there in just a second and kind of show this as analysis. But keep this in mind. What we end up finding are these trichoidal paths with these tornadic motions as they go forward in time. So just on the basis, what is happening here is you have these tornadoes that are circulating around a broader mesocyclone in time. So if you look down here towards the image, towards the bottom, right in this area, we're going to see that what we're finding is the red dot is the individual tornado. The blue circle is the broader mesocyclonic circulation. And so what we're seeing over time is the complex as a whole moving towards the northeast. But these tornadoes are actually circulating around that broader cyclone in time. And so we're going to show here, we're going to back up, and we're going to pull in some more detailed GR2 level analysis as we kind of talk through this case. So this is looking at just in Meriwether County, just to the southwest of the Griffin area. And as you can see here, we have the Griffin area on the map right about at that location. This is as the storm complex is headed in towards that Griffin area. So as we advance forward in time, we see what we're starting out with here is originally a broader mesocyclonic track here. I'm going to point the arrow on the upper right portion of our four-panel diagram. And we can even see down towards the bottom right, there is a tornadic debris signature that is just south of this Alberton area. So as we go forward in time with this circulation, we can see that we end up having a surge in the gust front out ahead of the circulation. What this is happening is it's going to occlude our broader mesocyclonic circulation as we go forward in time. So right at this point, if you look down here towards the bottom right of the velocity image, we see the gust front is surging out ahead of our original tornadic circulation, which was more or less going down this highway road here. And so what happens is now we have inflow that's well out ahead of the storm, but we still have outflow that's coming down from the north and wrapping around the broader circulation. And so what's happening is we're changing our storm mode at this point to where we can see more of a larger scale circulation starting to develop, but we can still pick out individual vortices, tighter vortices where these tornadoes are actually starting to form. Down here at the bottom left, you can actually see this in a field that we call INROT, which is basically looking at the beam relative vorticity on a singular scan. And if you follow this blue line in a circle, sorry, I got blue on blue, so it's a little bit harder to see. So let me change this color here to a yellow. That's going to pop more a little bit. as you can see here in this field, we can actually see these the levels of blue, which is positive vorticity, actually organizing themselves into a circular type of structure. So as we go forward in time, we're going to watch these individual tornadic circulations move along with this broader cyclone. And so I'm going to stop it right here again, and I'm going to draw your attention to the bottom left. These are looking at spikes in vorticity. And so we can think of this in a sense as where these tornadoes are actually starting to form, where we see the increases in this field. And so as we go through this, we can actually count 1, 2, 3, and at most 4 circulations that we can identify within this singular mesovortex structure. And up there on the top right, we'll point them out in the velocity field. There's 1, 2, 3, and 4 that's actually rotating around this complex at a single point in time. And so what ends up happening as these things go through, we get that trichoidal path that we just showed a little bit earlier. More interesting still, well, maybe not still, but along with all of these diagrams that we have going forward, what we find, going back to our original animation, was that not only did we have multiple tornadic circulations on the ground at the same time, rotating around a singular larger circulation, but we found that whether it may have been because these storms were in close proximity to each other, or maybe the smaller tornadic circulations were rotating around the broader mesocyclone even faster than the larger ones, which is something we actually observe in the atmosphere through other different physical means. But we found that these paths often interacted with each other, and tornadoes, the smaller tornadoes, were often absorbed into the larger tornadic structure itself. And so look forward for our animation. We can actually see that a little bit happening here as we go forward in time. So you'll notice right here we have a second tornado start to pop up, and this is going to be just to kind of the southeast. Then as we go forward again, we're going to watch that cyclone go forward in time. You can actually pick out this trichoidal path if you were to follow just this red line as it goes up through time and then starts to pivot there to the east. We kind of see that trichoidal path in motion. But what is happening here with some of these other paths, take this Scion path, for example, up towards kind of the middle center of the screen there. We can see it right here. As this thing starts to pivot on the southwestern side of the mesocyclone, it ends up getting absorbed into the yellow tornado path here, right along the Spalding and Pike County lines. And then as this red circulation up to the top ends up getting just to the east of the Griffin area, we actually end up seeing first this yellow tornadic line merge into that track, and then this green tornadic line then merge into the red track as well. And so we're going to see if we can break this down and locate these changes on our GR2 analysis as well. Make it a little bit easier to see. We're going to zoom in and slow it down, kind of show these different interactions happening all at the same time. Change this to black color. Here we go. So I got to switch back and forth between being able to draw and being able to show kind of these images on here. All right, so bringing it back in time, this is looking at roughly 4:12 p.m. as multiple circulations start to form here in this imagery. We see right there towards the southwestern side of Griffin County, we have one of these tornadoes starting to spin up here and pivoting to the east with time. As we see, we go through several images where this tornado is almost in the same place. And then as it starts to push to the east, we end up getting a real surge in what we call translational motion. Now, this is added storm motion to the tornadic circulation that ends up helping to enhance the wind speeds on the ground at that time. So when we show the final tracks in the motion, while we were able to identify the tornadic circulation pushing to the north here in that far southwestern portion of Spalding County, we weren't able to observe really a whole lot of damage in that area until we add this translational motion into the tornadic circulation, which really enhances the wind speeds in those areas. And that's been a common theme in here as we go forward with the storm complex in time. As these vortices start kicking towards the east very quickly, it adds a lot of translational motion into the storm, which enhance a lot of the damage that we found. That on top of when we have these change in storm tracks with these tornadoes, that often is correlates when some of these tornadic circulations were able to be absorbed into each other. That in of itself, take this one for instance. Basically what we see here is we have one tornado that's going to be starting right around here, pivoting to the east, and another tornado that's on the southwestern flank of the broader mesocyclone start to pivot up towards Griffin as well, and then these tornado tracks end up starting to merge. So as we go forward in time, we can see that happening right there on the eastern side of Griffin. And as Keith is going to show you here in a little bit, this area here right along the highway just to the east of Griffin, where we had 3 tornadoes essentially merging in a very small area at once, ended up creating on the bottom left, you can see extremely high velocity, vorticity in that one particular area. As you see on the bottom right in the correlation coefficient, these heavy blues that we see here that's also co-located with, on the upper left, you can see high reflectivities, are indications that we have a lot of debris in the atmosphere being sampled by our radar. So at this point in time, not only do we have 4 translational motion, we have 3 tornadoes merging with themselves in a very short amount of time, which enhances the vorticity of that one particular area that actually causes some of the highest damage indicators that we were able to pick out with this entire complex at this point in time. And so as we go forward here, we can see that again just to the east of Griffin, where the red, the yellow, and the green tracks all merged in a very short time frame of one another. And we'll run through this animation one last time to kind of get that sense. Blue, there's that pivot here now with the yellow track. The red track's going to pivot into the yellow and then the green tracks, and all that vorticity ends up getting absorbed into the storm over the course of only just a couple of minutes. So again, as we go through these strange path motions, what we're actually seeing here is the tornadoes rotating around a broader mesocyclonic circulation that is itself, that mesocyclonic circulation is itself moving towards the northeast with time, which is why we end up getting these really strange, almost looped or semi-circle tracks with time. So this is a nice animation we have here in the center of the screen, but keep in mind, this wheel is actually turning clockwise. In our instance with these low pressure systems, we typically see them turning counterclockwise. So you'd have to flip this image on its axis in order to get a real sense of what we're having. And as an end result, as we take that model of, or that template that we have of these tornadic circulations and compare them with radar data, we end up getting an end result like this. And I'll turn it back over to Keith a little bit to talk about how we compared the damage that we found with these circulations on the ground, with the satellite imagery and this overall template of where these tornadoes are growing with time to kind of get our end picture that you see here. Keith, go ahead.
Thanks, Kyle. Absolutely fascinating analysis. And one of the reasons why we were able to actually conduct this was because of the proximity of this area to our radar. So we were able to resolve at a higher resolution some information that we wouldn't necessarily have been able to do at a much further distance from the radar. So that is one of the reasons. But so what you're seeing here is the end result. These are our official tracks, and they essentially line up with the animation that Kyle showed you a minute ago. And one of the things I want to point out, it's probably going to be best in yellow on this background, we have 3 pivot points. Here's one here, here is one here, and here is one here. These were circulations that actually started from the southwest and pivoted. And this one actually comes all the way in from the southwest, even though the damage is weaker in here, consistent with these arcs back to these other 2 pivot locations. Those are 3 pivot points. We also have 3 merge points, which I will highlight. I'll change it to a white. Here we go. We have merge point 1, merge point 2, and merge point 3. Merge point 3 is actually fascinating. I'm going to zoom in on that in a minute. Merge point number 1 here that I've highlighted first. Interesting because this track ends up being an EF2, but it isn't an EF2 until we get this merge, and the downstream damage from this merge point was enhanced as a result of that merging, we believe. So we end up getting EF2 damage just downstream of that merge point. Likewise, the damage in and around these merge points is pretty excessive. Thankfully, it's mostly in a wooded area, but it is on the heels of the EF3 damage as this one pivots and swings, especially once it crosses Roberts-Atella Road. This particular tornado enhances very rapidly, and we think some of this vorticity was being fed into it in that region on a northwest axis, and so as these tornadoes are starting to phase out, a lot of that energy is being tapped by this northern circulation. So ultimately, that's what we have for the tracks in and around the Griffin area. And what I'm going to do now is I'm going to drag in some of this imagery and show you what it looks like on a larger scale. Back to where we are. Here's that region. Turn off the points. Actually, I'll leave the points on because we're going to want to click them. So here's what we've actually drawn. I'm going to focus your attention to, I'm going to start up here at the EF3 damage point area and some of the imagery. It will take a second for that to load. Bear with me. There we go. So this tornado coming in from the west, if I zoom out just a tad, we were able to follow it through the trees. In fact, I'll zoom in partway before the EF3 damage and let you see the tree damage. Here comes in fact, I'll zoom in a little bit further. You can see all the individual root balls of this particular tornado coming in from the west. Get some interesting tree damage blown to the north. It gets pretty extensive, and keep in mind that image I was showing you earlier with what it looked like on the ground, and I'm sure it's a lot of snaps and a lot of uproots in this vicinity, but here we go, continuing to the northeast, just following this tree damage until we reach this area near Kendall Drive. And we actually have a couple homes that were completely destroyed. You can see these trees are actually blown back to the west. We got some blown to the east. These here are blown to the northwest. Clearly probably not a tree standing. I know when we were down there, we didn't see one standing when we were down in this section on the ground looking back to the south and the west. Further to the east, you see more homes that were completely destroyed. These two in particular, this one that I'm highlighting here, let me get my highlighter. This particular one here was still under construction. You can see just basically by the boards, there's not a lot of other material that was spread out from this one. One thing of note, the walls were not anchored into the concrete. Hence, we believe that this particular structure was and would have been damaged at a lower wind speed. So we weren't able to get a higher rating out of this as a result of the fact that it was not anchored down. The same thing applies to this particular house here. In fact, I'm going to zoom in on that house and click one of these points so you can see the vantage point. So that is looking at the slab, and you clearly, if you look at the base here, oops, that's not my pen, I want my highlighter, there we go. The base, these walls were not anchored into the concrete. These are the carpet tacks in and around the walls that were completely gone, but the outside and the exterior walls were not anchored in. The other thing we note back here is where the plumbing was. There was a bathtub, the toilet, and the shower that was back here. They were actually completely ripped away. This was not piled up by the homeowner or by anything else. The wind piled all that damage up in that location because we were there not too many hours after this particular tornado, so there wasn't even a time to pile it up. It was actually piled up on its own naturally. So let me get out of this and zoom back out. So that particular tornado, this is where we got the intense damage, right in and around where we were seeing these mergings. So now I want to I'm going to go back to the southwest where we have the merging and the enhancement, just to show you what we found as this particular tornado, as it developed and pivots to the southeast, how we know we have a tornado coming in from this direction. I'm going to zoom in here. Not only do we match it up with what Kyle showed you on radar, here's the tree damage. You can see the trees blown down coming in from the west. And an absolute indicator of a tornado is a convergent path. We actually have trees blown down this direction and trees blown down into this direction to give you an absolute convergent line right through here. And so that's how we know we actually had a tornado wind damage as opposed to straight line wind damage in this particular spot. Zoom back out. So we followed this damage down through here. There was a crossing point from the one moving up from the southwest. The one coming up from the southwest would have been about 2 minutes prior. In fact, I'll drag in so you can see with those two in mind. Here we go. So keep your eye on this particular cell right here. And it's going to go to the north. See it going to the north? And then keep your eye on this cell right here. This one is going to go east. Just that. And so we got this one going north, this one coming east. And so we ended up with a crossing point roughly in this vicinity. The one moving north wasn't causing as much damage as it did or as it was earlier. We do believe this barn was impacted by the first one. It was about a 1 to 2 minute delay, but here's the one coming in from the west. You can see it from the northwest part of the screen coming in and continuing southeast. I'm going to follow it further south and east. It's beginning to approach the merge point near the Pikes-Spalding County line, and you can start to see damage enhancing in this area. In and around this point, there's pretty widespread tree damage, some coming up from the southwest, some coming in from the west. And so it was in and around this area where these two particular tornadoes merged. And then shortly thereafter, we get EF2 damage. There's this barn that's destroyed right here. Upstream of that, we have another structure destroyed, EF2, just downstream of the first barn that was destroyed. This structure here, blown into the woods. And so a lot of tree damage through here. You can see it continuing just from this distance. I'll zoom in for those that want to get a better look at it. See all the trees that are blown down through here with that structure that was destroyed in that field. So clearly the merging had an impact on the enhancement in that region. Something else of note, and it's interesting, as this particular tornado approached the quarry, this rock quarry became a figure. We could see it both from the air and on the ground. This tree damage essentially stops, or there's obviously no damage that occurs in here, but we have to pick it up further north. So we believe this disrupted the circulation enough to where we get a new formation further north of the quarry and swinging into the east. And so now I can pick up this tree damage coming in from the east. You can see it's pretty extensive through this region. And here's coming up from the north into this convergent line area. And so we have quite a bit of damage in this area along Rover-Satella Road. And you look how far, if I zoom back out, look how far away we are from the EF3 damage way up here. That's how we know we have multiple tornadoes. The other thing of note is there's very little damage in this sector right here. And it's because of the way the tornadoes align. So this sector here, this is about 2.5 miles across, and there is consistent damage, 2.25, 2.5 miles across in that sector with the 3 tracks coming together. So last thing I want to do before I take too much time is I'm going to zoom in on this eastern track that's swinging up from the south. And if I zoom in here, you'll clearly see, once the resolution comes in, all of the tree damage in this region. Again, blowing to the north or the northeast. Here's some here. Here's some here on the east side. And so we were able to track this particular rotation to the north through this neighborhood. May have been some wind, may have been the second circulation, may have been part of this one. North, destroyed these barns here as it's going north. And you can see that they're actually over on this side, there's root balls blowing to the north in the direction that the tornado is moving. But it's really, once it gets up here, it's where it's fascinating and it starts to come together. So I'm going to zoom in and start over at this pond. So it's coming up, was it Delray Circle and Princess Circle? Wait for the imagery to load. Give it just a second. Here we go. I zoom in, I want you to see embedded in there, there's house damage here, there's some tree damage in the forest here. But look up this lake and follow, you can see tree damage up this creek, so to speak, where there's almost certainly a circulation up the creek. More intense, and boom, we're coming up from the south, we're coming in from the west. This is clearly a merge point where we have circulations coming together, and probably safe to say every single tree was blown down or destroyed in this vicinity, with the trees coming in from different directions. Pretty fascinating to look at this from this perspective, to almost prove without a shadow of a doubt that we had merging circulations in here. And this is just south of Highway 16 before it crosses Highway 16. So if you drive Highway 16, you can look to the south and you can see all the tree damage down through here. You can see this merge point area certainly stands out on satellite imagery. So absolutely fascinating to look at it from that perspective. So that is what I wanted to cover, particular on these cells. What I'm going to do now is back out and start shifting a little further east as the cell, and I think I'm going to drag this back in because it's important to note that the cycle begins to repeat itself. So we get the Spalding tornado, and I want you to note right here, we have a new surge developing on the southeast side. So that's out here, away from what's going on in Griffin at that time. And go, step forward, boom. We now have a new tornado on the ground southeast of Griffin. We've got what's going on in Griffin with a new one, and as evidence from the new tornado debris signature, this ultimately becomes another EF2. That it begins to shift east with time. You can see on the tornado debris signature on the bottom right, the velocity on the top. I'm going to zoom back over here. Ultimately, this is what it ends up doing. We end up getting another one to develop. So I want to focus on these three circulations that actually cross I-75 roughly around the same time period. Oops. So I'm going to zoom in on the northern one, and this is what it looked like. East of 75, you can see all the tree blow down. So clearly that storm crossed I-75 into Locust Grove. There's a lot of tree blowdown and damage in the Locust Grove area in southern Henry County. I'll zoom in on a few of those spots in a minute. Going further south, this is near Jenkinsburg Road. This is actually inside Spalding County still before it goes into Butts. You can see the tree blowdown here as well. That's spread on that square at that cross point. And then further south, here's the third one. This one developed back to the southwest of this, inside Butts County, and hit this warehouse. You can see the damage to the roof on that large warehouse. And that, when I tell you that's a very large warehouse, Each one of these little stalls is a truck, semi-tractor trailer on the ground, so a pretty sizable hole in that roof. The tree damage on the opposite side of the interstate wasn't as extensive. It was a little bit weaker of a tornado, but nonetheless, it did cause tree damage further down the stream, and we could follow it basically paralleling Highway 16 to the northeast. So real quickly, I'll just drag in GR2 so we can follow this. The difficulty we have once it starts getting east of here is we start to lose the resolution because we're looking up in height. But it's at this point, here is storm 1 coming into the interstate near Locust Grove, not quite there yet. This one's crossing. You can see by the TDS signature. Here's the southern one that's hitting the warehouse down here. Roughly about the same time the second one is hitting, and then the other one hits a few minutes later, or a minute or two later. Okay. A little bit further east, the one that crossed near Jenkinsburg. Again, it starts to get more nebulous. If I zoom way out, you can see what Kyle was talking about, this large circulation here with this line that extends out and around it, almost like a squall line, and it becomes sort of the inflow feed line for this mesocomplex as it continues to truck north and east. But it's at that point, I'm going to drag in the, I got the radar and drag in. Drag us upstream here. I'll zoom in a little bit on Locust Grove so you can see pardon me, some of the tree blowdown from the northern storm. Zoom in on this particular, some of these housing subdivisions. We're very fortunate that it was EF1 damage as it's coming through this section. You can see how extensive the tree damage is in and around these neighborhoods. There are some blue tarps there. You can see on satellite, but see how widespread the tree damage is. And this basically continues east-northeast. Here's some damage here. I do know, yep, there's a school there. It just missed or was on the periphery of it. Actually had several schools that were impacted by this particular tornado or these tornadoes that day, starting in Troup County. And the tree damage actually continues east-northeast, and I could zoom in and show you that on each one of these satellite imageries. The same thing applies further south on this particular track. If I zoom in here just south of Jenkinsburg, I can show you this particular EF2 track. Of course, it was an EF2 back to the southwest. Wait, oh, I'm at the edge of the track. That's why it's doing that. So here is the damage on the ground. You can see it going to the northeast. That's how we know we have a track there. And of course, the satellite imagery stops there. One other thing, at the beginning of this track, where we got the EF2 rating, I wanted to show you what it looks like from the air as opposed to what it looked like on the ground. And this is about as good of a EF2 tree damage as you can get. So here comes the tornado through the tree line. You'll see it here in a second from the southwest. I highlight it, draw, it's right here. And then you can see it starts to really expand in and around this region before it approaches the highway. What I want to show you is this tree damage right here. There is a house right there. I want you to see what that looks like from the ground. So we're looking back at that house. That's what that tree damage looks like from the ground. These are hardwoods. They're not pines. Pretty much the entire forest was snapped off in this particular location. And so this is what it looks like from the air. We took that picture from out here on the roadway looking back at this house with EF2 damage, pretty significant EF2 damage. And so this house, pretty lucky. It almost looks like the core of it was just to the west of their house. could have been much worse for that particular house. But nonetheless, it continues east, and we end up with the 3 tracks. Now, once it gets past this point, we no longer have the luxury of satellite aerial imagery to help us. Combined with the fact that the radar resolution starts to degrade a little bit because we're getting higher and higher in the storm. We're getting to 2 to 3,000 feet. Not that that's all that high. To see these things, it just becomes a little harder to resolve them because we need to be closer to the ground. So this is as it's approaching Jackson Lake area. You can see it's like a large comma head. It's very occluded at this point, but we cannot find the tiny individual circulations that we were able to see in Spalding County, quite the same over here in southern Newton, northern Butts County. But we do know from ground surveys that we had damage as evidenced by all these points. And when you look in this particular area around Jackson Lake, there's points all over the place. And the best we could do is come up with 2 separate tracks fairly parallel to each other. However, it is entirely possible that what was happening near Griffin was also happening here near Jackson Lake. If I zoom in, some of the worst of the damage was in and around Jackson Lake. If I zoom in and show you this particular point, it's this one here. What it looks like on this street. There's that picture. This one. Here we go. Clearly, we had a tornado through here, and we ended up rating it EF2 based on the damage that was in and around this particular point. And also from the air. It did cross the lake. So there were a lot of houses that were impacted on Jackson Lake. This one shows the whole street. Trees down across that lane. It's this one. Show this. Yeah, you can see the extent of the trees that were downed in this particular region along Jackson Lake. Also, further north, we had trees that were blown down coming in from the southwest that didn't necessarily align. There was a gap in damage between these points. There was some sporadic damage in between here, but there was a clear gap, which enabled us to try and define a second path to the north. How that, if it exactly transpired, it's hard to say, but that's the best we could come up with based on the damage on the ground and going through it extensively. So back out of that. Oops. And get to our summary slide. So obviously a very rare, very unique and complicated storm system occurred that day. And it was only through the high resolution data and the analysis that we were able to discern the various tracks and the motion that these various tornadoes took that day, particularly on the west side of all of it near in Spalding and even to some degree in Troup and Meriwether County. It is likely that something similar happened in Butts, Newton, Jasper, but we just don't have the same data resolution to be able to resolve the minute details and the minutia of the various tracks. But it is likely that there were, and we already have 2 tornadoes on mapped out over there, but it is possible that there were additional ones. In all, there was a total of 14 tornadoes that occurred that day, 10 from this one particular storm. Ironically, a very similar system actually affected Wilcox County to the south. Thankfully, the environment wasn't as unstable as it was when this one went through. And so we ended up having 2 of these types of systems with crisscrossing and a larger circulation with smaller embedded tornadoes occur that day. And so I want to thank you for your time and walking through this with us. And hopefully we'll get some of the final updates out and you'll be hearing more about this particular event. Need to connect with us? Here are the ways to do so. Thank you.